record on this computer. Hopefully, yeah, it's recording is on. Okay, guys. Yeah, so as you can read in the title, so it's what I'm trying to do is demystifying the RSS. And I was thinking a week what I can do. So I decided to make a presentation for it because I think some pictures say much more than any words, 1,000 words. So let's start. Oops, how can I control this? Okay. So these are my disclosures. So I'm not a mathematician. So, but studied algebra, calculus, and statistics in the universities I attended in my life. So, and of course, I can misinterpret anything, miscalculate what I have done in this presentation. So, also I'm an SPO, as you guys, and the other holder either. So, I probably biased, but yeah, luckily I'm aware of it. So, and also, of course, I have no any affiliates with any entities relating to Cardano blockchain. So, and I'm not a member of any pool alliances, Poker, etc. So, yeah, just I'm at a TG, a Telegram group, and the official Cardano forum. So, yeah, the last one, I skip it, but yeah. Okay, first, so what is the agenda of this presentation? So we have a three main parts of the RSS. You know, how the rewards, well, rewards is calculated for a epoch. This is the first part. I won't discuss this. And the second one, which is the RSS, the reward share scene, which is for calculating the total epoch reward for a pool and how it's distributed between the operators and the members. So that is the main topic here. And the last one is the ranking, which is I won't discuss here at all. So yeah, why I created this presentation, because the formulas are very scary, you know, hard and confusing, and there is no meaning for the people. So when we see a formula, we just see numbers and it has no meaning beyond that, you know. So that's why I just create this presentation to like provide some ELI 5, you know, just to understand the fundamentals of this. Okay, so just the next one. So, you know, this is a formula and it's very scary because we don't know anything what is behind it. So, and what is the function? It's just simply just calculated pools epoch reward. And I'm just jumping this because has, and also, yeah, I just want to, if you have any question or anything, just stop me and I try to answer. So first, in ideal case, yeah, we should have a K number of fully saturated, full pledged pool. As you can see on the top of the page. So the reward is just the split between the K number of fully separated. That's all. But in real life, we have much more or less, but now it's much more than fully saturated pools, which are certain percent of saturation, as you can see. So one pool can have 0 saturation, one can fully saturated, and the others between. And so what is the main purpose of this presentation is providing how these reward for a pool are calculated and what's the meaning behind. So I'm just just selected one pool, and its ideal pool reward is, you know, it's the whole reward for all of the pools multiplied by z0 underscore 0, which means that is the ideal. But we wouldn't achieve it. Maybe some pool, but in globally we wouldn't achieve this kind of equilibrium. So the more realistic, the second, the green line, when you can see the pool can have some reward based on its stake. What you can see on the, like a slider, you know, the max is the zero, Z0, and the lowest is the zero reward. And so the maximum pool can achieve is based on its stake, so the RS, because it can't go further, because the formula I showed you in previous slide is kept by the Z0, so it doesn't matter if any pool has a higher stake, it just will calculate it by the Z0. So the next one, so the so how do I explain this? So based on this max, so what is the minimum a pool can have? So this minimum is based on the A0, what we always referring to. And what this simply means, if you can see this orange, box in the, and it means it is the 100%, and the A means if you add that A% to this 100%, will no, to this orange one, it will be the 100%. It means if the A0 is 30%, so the base is 76.9%, which you multiply as 1.3, which is 30%, it will be 100. So this is the minimum. So between the currently 76%, what an operator or a pool can have, to the max the stake, based on the stake level. So, and the rest, is the blue one, is based on the pledge. Because it doesn't matter if we have zero pledge. Yes, I didn't want to, so I'm not considering the zero pledge here, because in somewhere in the code, if we have zero pledge, we would have zero reward. But based on the formula, we would have this minimum idealistically, but we won't have it, because if we have zero pledge, it will cancel out in the code somewhere. So, and as you can see, this A, so it can go to max to the S. So if A is 0, which that would mean this orange box can increase max to the S and will become as a green one on top of it. And if it goes to the infinite, it will be less and less and less and less, but we'll never reach the 0, because you can see this is the fraction, which is the bottom, is the A plus 1 plus A0, which if you increase the A0 to the infinity, it converges these to the 0, but we'll never reach it, of course. It will, but yeah. So the pool reward is based on this, the minimum, and some additional, the blue one, which based on pledge. If pledge is 0, you will get just the second line, just the orange one. And if pledge is the S, the stake fully pledged, it means you will get the green one, but it will be split these two, the orange one, the delegated stake based and the pledge based. So this is yeah, the reward function. And yeah, but as I told, it's based on pledge, and this pledge can be seen as or considered as a slider on the blue box, yeah, which can reach the max S and reach the 0 and in between. And that's all. So why I put here is because these can be considered seen as terms, as you can see on the before on these, these boxes, you can see there are RZ, RS, and these are just one terms in mathematical terms. And when you can see two boxes, you can see two terms because the first part plus next part will be the reward. And in the first one, third one, you can see three terms, which means one the minimum, one the based on the pledge, and one small is which is less than the minimum. And I think IOG is decided to use these as a quadratic function and not linear because this RSS function is not linear at all. I will show you why. Because it will be linear, it will be always grow and decrease like this black thick vertical slide between the S on the and next to the red box, you know. But it's a little bit lower, so it means they make it quadratic, so it's not linear because it will be very easy. Just linear, and you just draw the slide left and right till the S until the minimum. It will just linearly, allocate this reward. So next one. So, and what I did, I just rearranged these formulas, these terms, and which became the well-known terms. So no any magic inside. These are just three terms which can make this function very difficult to understand, but it's very simple. And I told it's not a linear, it never was, and I told it, I think 2 years back, but it's a quadratic, as you can see, because it depends on the p, and there is a p square in the red box, and the p it could be just represented as a x square root plus b x plus c, and as you can see, this p square root is minus. It means it's a concave. So, and not a convex. So it means I think I show you if I can in Desmos, but I'm not sure. I will show you later. So what I mean is, so anyway, I just rearrange this and just put, and you finally will get exactly the same formula as these FSS RSS reward function. I think so. Do you have any questions, guys? Or is it understandable or makes sense?
One question.
Yeah. I can hardly hear you. Can you be?
Yes. Yeah, sorry. Oh, I probably have got the wrong mic turned on, but yeah, I've only got one, which I think I understand from what you've got in here, but I just want to make sure I'm not misinterpreting it. So in this case, when we show the top green bar, is that saying the maximum, the pledge is also the full stake of that pool?
Not full stake, because a full stake, it will mean the S equals zero. So okay. it will be full. So if based on the stake, the S mean, that's why I named it S, because it means stake, delegated stake. So it's based on stake, and the P and the level is pledge. So that's why I used here the P and S instead of the sigma and S in the original formula, because it may confusing the people. But I think it's easier. The S means stake based, P means pledge, A is A. So I didn't do. So yeah, the green means the full.
Where is P?
Sorry.
Where is P for the green?
Yeah, can you see in the fourth line, and there is a P on. Well, I will explain this. So back to the first. So this slide is like the based on stake. So the Z0 is the max. If you fully staked, it means you have a full saturation. The S will become the Z0. So the whole, the white part of that will be 0, and that will be the your pool reward. If you are fully pledged, of course, because it means, the green means based on stake, but fully pledged. And the second row, it means stake, but zero pledged. And as you can see, the third and the first, the same, because it's fully pledged. I just show it as two parts, the minimum part and the pledge base part as the blue one, if it makes sense.
Okay, thank you.
So because you reward always, I mean, have two parts, the minimum part and the pledge base part. So, and you can't go under the minimum because the minimum is always weighted by A0. If A0 is higher, then the minimum is lower, but that means the max always be the same for the reward. But so you can get just max reward for a pool and you can't go higher. This is a very important property because it preservation of value. You know, you can't make just things from the thin air. You know, it's so it's a math, so and physics, but not here. So you need to preserve the value, so you can't go higher. So I hope this makes sense. If not, just please ask, because I think it's very simple. So the reward is based on the minimum and the pledge base, and that's why I was trying to explain. But this is much more complicated than the reward distribution. I think you will get your head around it when we go to the next part, because it's much more simpler and can be understood much more easily. So the next one. So the bad, So what are the reward distribution? The first, so how does it work? The system calculates the whole epoch reward, what I'm not discussing here, you know, and based on that, that is the R, big R, it is for all of the pools, you know. And the function, the RSS function, is just calculate your pool's reward based on your stake, based on your pledge, and based on the A0, and of course the K, which is the 0. So these are you know, the properties, and they can be dynamic, like the stake is always, they can be changed by the epoch, or static, I mean semi-static, like the A0 and the Z0, which is based on K, and the pledge can be semi-static because you can increase, but it's usually doesn't change between epochs. So the next part, so first we got a reward for our pool, but how do we distribute these reward between the operator and the members? And that is the next part. So we got the, you know, the reward, I call it FSP because it's based on the function, so, and it's based on the stake. And also I haven't considered the performance here, anything for simplicity, sake of simplicity. So we just assume we got a full what we can based on our stake and pledge and the other parameters. So, and I just call it F. So as I wrote here, it simply just split the pool's calculated epoch reward between the operator and the pool. And we are talking about a specific pool now, it's not the pools. So the first, so as IOG we are considered, they will allocate some cost for the operator, which is some constant arbitrary value is C. And as you can see, if we allocate some C, so what is left? Of course, F minus C, because we have some reward, and you can replace this F with R reward, pool's epoch reward. So if we allocate to the operator the C, so what we left is the rest, which means the reward minus the cost. And also they introduced margin. So they want to allocate some percentage of the reward to incentivize these SPOs and pools to participate in staking. And of course, the second, what is left then? So because if we allocating, the margin can be maybe 2% or anything. So the left is the F minus C times the left of the margin, which is if we use M as 2%, then the 1 minus M will be 98%. So and imagine these are terms. So I'm talking the first is just one term. The second is the two terms, which mean C plus F minus C. And the third is also three terms. C plus F minus C, M plus F minus, because of preservation of value, it's never getting less or more. It will be always the reward and be operating on that. So I just wrote here. So why is it confusing? There's M or 1 minus M, and it just simply just means just one. If you say here, so because M plus 1 minus M, which means 1, and if you multiply with the F minus C, so these, when you introducing in one term something, you introduce something the other person is not to preserve the value of this one. I hope it makes sense, but sorry, I can't explain really. So the next part, so how do we split these leftovers? Because the C and the cost and the margin is allocated to operators. So we have something left, and we would like to distribute or split between operators and members, and these are based on the pledge, of course, because if you are full pledge, there is no room and there is no left for the members at all, because everything is yours, isn't it? But if the pledge is zero, of course, again, I'm not considering zero pledge means zero reward here, but it's in the code somewhere. It means everything will be the members, and the operators just will get the cost and some percentage of the rest. So, and as you can see in the purple and the green one, so if we decide the left side, the purple one, is a pledge based, and the right side, the green one, is the rest. So the S minus P, the stake minus P, and that will be represent the members, and the purple will represent the operators part of this reward. So, and also in the paper they use T instead of S minus P because every member has a small portion of this green one, and I just considered here as all members rewards, because I don't want to go, because it will make you much confused than it should be. So, and also this P can be interpreted as a slider as before, because if the pledge goes higher, then the left for the members will be lower and more for the operator, and this kind of like play with like a slides. And as a final part, if we just include these, what is the left, and the operator is just simply just a rest, which was on the third row on the blue, times the P per S, which means a percentage of the stake. So if you half pledged of the stake, you will get 50% of that, and the other 50% will be the members. And if it will be full pledged, means PS will become S divide by S once, all will be yours. If the P is 0, then you won't have anything but the cost and the margin part, and everything will be allocated for the members. So I hope it makes sense, you guys. And also these should be considered as terms. These boxes here, just imagine as terms, you know, the C plus something, because it's simpler math. So as you can see, finally, we have these 4 terms, which is the reward divided by, and 3 terms of it goes to the operator, as you can see in the button, and the right side goes to the members, and that's all. And if we rearrange these all formulas, you can see it's exactly the same, but it has meaning now, because when you look at the formula, you wouldn't understand what the hell is going, because it's number. What I don't understand. I can't have any meaning. But now you can just replace it, these terms, as these blocks, and you would understand how fully. So I think, yeah, that's the fundamentals to understand. I'm not sure how understandable it is, but I hope it's not too difficult, because it's, yeah. And any questions?
It looks great to me. Very interesting.
Oh, yeah, a lot of guys have just joined in. Thanks.
Very helpful. Yeah, very cool.
Hi guys. Yeah, sorry, I'm not sure. Yeah, but this recording, so you can recap later time, and maybe put somewhere. Maybe I will create a GitHub repo or somewhere, or I just put in the guild. So this is the fundamentals for these functions, and hopefully it's not too difficult. This one, the effort calculation is quite difficult because it's a lot of formulas, and why PS here and P per Z here, and why not P per S? And I won't go to the details, but if somebody interesting, I can explain everything here. But I think it's not all about it. It's all about just you understand these like as terms, you know, as blocks, as terms, and what it means. So okay, this is all for the fundamentals, and the next one, the tricky ones. So what is the issue with this RSS and no RSS distribution? So when we go back to here, you can see this, when we allocate the C, it's an arbitrary number. It's not weighted by the stake, but it's a fixed number. And when the stake is less, the cost becomes higher in percentage wise. And when the stake is go higher, this cost will be less in percentage. Of course, because if you just do the S divided by S, and when the S is higher, you know, the cost will be low. I mean, percentage by lower, and when it goes lower, it will higher. And same applies to this one, the margin one too, because this margin is relating the stake, and if the stake is higher, the margin will be higher. And when the stake is lower, the margin will be lower. Okay, so this need to understand. So what is the issue with this? So I just wrote some things that the Cardano protocol should offer some Sybil protection to prevent some Sybil attacks, different type of, and I just wrote here 3 type of Sybil attacks. So having only very few number of pools that control the total delegated stakes, maybe in the worst case 1, you know, just one very big pool, no anything, and this control the whole delegated stake, 31 billion at the moment. But of course, it's prevented by the K and this RSS function because it's kept by Z. So it can't happen. And the second one is generating as many pools as the adversaries can. And it's also eliminated by deposits because we need to pay deposits. It's like a transaction fees for transactions. So how we prevent DDoS in blockchain is based on transaction fees. Because if you don't have transaction fees, everybody would create as many transactions as they can, and they just flood the system, and which will die eventually. So here we eliminating this by deposits, when you registration fee and this kind of stuff when you register a pool. So that's one. And the third one is a power accumulation of multiple pools owned by one entity. So this is the very tricky. So how can we prevent this? So is it even possible, or what the hell is going here? So I just last week when I was thinking of and showing this graph to you guys, I decided to create this presentation because if I would show this graph, it wouldn't have any meaning. But no, I think it has some meaning, what I wanted to say. So the issue is here. You can see in the x-axis is represent as pledge, and the y-axis is as a percentage. And as you can see, and I did some vertical lines here, that the full saturation, the 10 million pledge, 1 million pledge, 100K, and you can see there's a very rightish side of this, is very small part of this whole stake, whole full saturation. This 1 million is just almost, you hardly can see the 1K, 100K. So at this thick red curve represents these two red curves represents what the operators can have as a minimum based on the saturation and pledge, but here is fully pledged, and the max. And the issue is that there is a black point in the middle, you can see, which means that if you have a pledge on the right side, you are not incentivized to do a full pledge, but do some pledges because you can earn more profit. You can have more yield if you may just invest maybe just 1 million. As you can see, it can goes up to maybe 15% instead of if you have not 10 million, but is maybe just 20 million, you will just get 8%, 5.8%, sorry. So the pool operators wouldn't incentivize to full pledge what they have. They incentivize to split their pledge to these amounts, much lower amounts, because what the pools simply want rationally, to get as much profit as they can. This is a rational behavior. There's nothing wrong with it. That's why the 1PC2 and others do. Just split and will gain. And even if, imagine you do a zero margin and you just invest 50K, you can earn 24K a year if you can have stakeholders delegated to you. You know what I mean? It means 48% a year and do nothing with zero margin. So I would split to 50s and create a bunch of them. Because if I can accumulate power, I can be good in marketing and this kind of stuff, I would earn a lot. Originally, it wasn't the case because the cost wasn't considered when I remember back to 18 and late 270s. Cost wasn't was just introduced recently by last year or maybe somewhere. And I will explain in this graph how it works when you sliding down and what does it mean. So this is the main issue. So this is a simple math. Of course, it doesn't affect the how the members, because they have different curve line. I mean, different curved line for the reward. So is it hard? I want to, that's the issue. I told Marcus I couldn't finish his presentation properly, so that there would be the second, that should be a second part, but I would say, yeah, I will just doing some. So just imagine. So what one can do, just forget the cost and just do a margin and allocate to the operator, because we have two participants, the operators and the members. Of course, I'm considering operators and members together at the moment. So what would be if we just give the margin to the operator and take from the members, as you can see in the this function, which will be the FSP times margin. This the first one is for the members, and the second one is for the operators. Yeah, it seems good, looks good, but what is the issue with these guys? Can you imagine what? The preservation of value. Because if you solve this, it becomes 2 FSP. So it can't be. So FSP in the first, the first function can't be equal to the second FSP. So it means you will halve of the rewards of both. So that is the issue. So it wouldn't have. So we can make it high to the as usual, but it means we need double amount of reward than we have, which means it's a monetary policies need to be changed and everything, but it's not good. So it won't help at all, but that will be the ideal. So if you allocate margin, you will get higher and the members will get a bit less, of course, and this will incentivize the pools to just have only one, because if you have these kind of functions, it doesn't matter how many so it doesn't matter if you create 1 million pledged pool, you will exactly earn the same as if you would put just 10 million pledge pool. So there's no incentives to have 1 millions, because it would cost you a lot more. So it would incentivize you to have just one pledge pool. Yeah, so this is not good. And I think I will, so yes, I think next time I will go to the shown and explain why is it bad for a lot of reasons. And I can explain these like a layman explanation. So, and the other proposals, but yeah, that's what I could create for this limited time, because this week I just decided I will go with the presentation because it's much more easier than just showing graphs, and there is no meaning behind these graphs. But we can go and now, and I think maybe there's more. Yep. And yeah, and I just open the graph. Okay. So any question? Sorry guys, because I'm just talking and I am not. Oh. Is it understandable, or is it very difficult, or?
Very interesting, understandable. Yes, it's
Good then.
Complicated topic, but you made it very, very understandable.
Okay. Yeah, that was my aim, because it's very hard. Understand the formulas if there is no meaning behind them. So okay. So first, here is Desmos. I'm not sure are you familiar with, but yeah, it's a very good tool. And okay, and back to the reward calculation function. So I'm just creating one, maybe just this, yeah, and just some opening, just very simple, and just what I meant. Oh, bugger, I can't. So we just make it here. Yeah. Okay. So I'm not sure I can do the double presentation, but maybe. Okay, so just go back here. And what I explained, it's not linear, because you can see here is a minus something times p square root plus something p something. It's can be very easily represented as I mean, not represented, it's a quadratic function. And so you can see the behavior of the, so just getting 0, 0, maybe. So I just take it to 0, 1, and 1, 0, 1, and the other one, but and so explain. So if the a is less than 0, it means it's kind of like a concave, you know, and it depends on how big is d. If it's a is very big, you know, it's not really flat. But if it's 0, it's completely flat. It's like a straight line, of course, because it's a linear equation. Then, because you will get just the bx plus c. It's a high school math, is not. So, and here you can see that this p square part is very, 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 very small, which means t is nearly straight line. That's why the people think it's linear, but it's never was linear. Just very when you go to small and small, it behaves like a linear, but when you zoom in, it will never. So just clarify that. So okay, now so the second point. So that I created these, you know, vertical lines where a pool can have, you know, and so there's with 10 million pledge, 1 million pledge, 100K pledge, and the saturation point. I'm not considering the above the saturation point, everything, because it will be make it difficult, but fundamentally everything works the same. So what I just show you, you know, it's, we would have, that would be very nice, this graph, okay, because it will incentivize the spools just, and you could create a very high margin. So it doesn't matter, because it won't take too much from them, you know, just, and you can have more benefits. And it's like the perfect solution, but we can't do that. Originally, if everything is 0, you know, it's the FSS function means these straight lines. This is the FSS function, RSS function. Sorry, I'm talking. Yeah, and this is the straight line. But and here I'm turning off because this is simpler. What I explained is not accurate and we can't use. So back to the real operator reward and the member has reward. So just explaining. So when I'm just showing this member reward, it's if it's everything is 0, it will goes up to the same level as RSS function. That's the base, because we haven't introduced anything, no cost, no margin, perfect. The member and the would have the same. And when we introduce the cost, it doesn't really affect the the members, it will just a bit less. But in whole, it wouldn't, they wouldn't have any change. I mean, drastic change. Same applies for the margin. If you just do it 2-3% of 5, it's not really do harm for them. So let's just set back to the original for the end. I will do 3% as just, and hit the slides. S, capital S represents the the stake, current stake, and the pledge is based on the, so if it's full stake and the pledge goes full, the member will hire it until it reach the S, because in that case it won't anything left for them. But in percentage wise, it will be always higher. And also keep in mind these graphs based on percentage of your investment and not arbitrary value of other. So if you invest 1 million, this means the 5% will be 50,000. So because that is how you can see, and not as arbitrary value, because value doesn't mean anything. If you put maybe 50K pledge and you gain 100 a year, it doesn't mean percentage wise what is the gain, what is the yield, what is the, so that's why in these graphs I will use the percentage everywhere wise based on your pledge, and these slides calculate that one. So it's, if higher the pledge, it will benefit the members. Why? Because it will get higher percentages. Not too many, but the minimum is, it can have 0. But if 4.8 and it's fully pledged 6.2, it's not big incentives, but incentives. So it's, if I would be a member, and I would rather delegate, of course, if there's no ideology or something, I'm connected to that pool, to the pool who provide me the highest yield, the 6th, maybe it's a half pledge or more, but I can get 6% instead of 4.8 or something. So this was the incentives of the RSS paper to do it, and it's worked very perfectly. I mean, yes, we can have discussion about it, but yeah. Okay, so this is the member. So I think it can be understood. So the next one. So the operators, I told, yeah. So the cheeky one. So if you click here, you can see this point, which is the turning point. It's a local minimum in a function. We called it in the university when you do calculus, which means this is the lowest point here. So this is and from left of it, you will get higher and higher in percentage, and right of it, you will get higher and higher. So if you have a 22 million and you pledge it, you will get only 5.8%. And when it goes up, that's okay. It will be higher rate, of course. And we can reach the max. Because as I said, the max is always the max. And the A doesn't impact the max, but impact the lower range of the reward, not the higher. So imagine, it's not really true, but I don't want to get in the details. So max is always max. So think of it. And that's all. So imagine you had 22. So nearly in the so from the left side here, you can gain a lot of much more than if you pledge just this one. So if you pledge 1 million, just go down to the million. sorry, hardly got, but I just, oops. Yeah, you will get 16%. It's much, much higher. So why would I do 22 million pledge when I can do 1 million pledge and I will earn 16% instead of, just what is here? 5.8. So these left side of this point is the tricky one, is the cheeky, which incentivize the pools. There is no exceptions. All pools incentivize to do this. But they not aware of it, but they know if they just put maybe 50K pledge, that's okay. And just a cost and zero margin, oh, they will earn a lot based on their investment, the money. So what the solution can be? The solution is very hard because the solution should be you find some function that will cut these, increasing curve and just create a straight line here from other 6%. I just can put just a x, y, equal, what was it? So just from the one to the left, just create a straight line instead. It doesn't matter if you have less pledge. You won't earn the max till the saturation level. That is, it will incentivize the view. It doesn't matter if you put 1 million or 10 million pledge. You will have the same percentages of that one. And when you get a higher, you will have benefits for these increasing. But this is much better than the straight line, because a straight line will be just, you will get less. But is it possible to do that? Yes, it can, but it's very hard. What I showed you here, what I show you here, and I showed in the past. So this is the math of that one, because it's a quadratic function and a derivation. Because this saturation, not saturation, inflection point or minimum, local minimum of the function, what does it mean? It means this is the point when this curve function, meaning the reward function, first derivative equals 0, because the derivative is when 0, it means the slope is 0, means there is no any. So, and when you solve it, you will get a cubic function, and it's very hard, but it can be. I proved when I wrote it 2 weeks ago, I just sat down in the weekend with a pen and paper, and I got it, fuck it. And yeah, it can be solvable. So there is hopes. Or not just this, maybe some other proposals, this is just one. But the issue is that you can see it is increasing to the infinity when you pledge goes on. And also we need to find the threshold. Okay, what is the cost? What is but it doesn't matter if the line is this one. Anybody could find a sweet spot, to just create as many pools and have good marketing. They will earn a lot, which means, I guess, not decentralization. So I'm just putting back here and just get back to Sean. And I was trying to explain you guys a lot of times that what is the issue with it. So Sean, I don't want to get in the details, but what he does, he's just changing the pledge part of it. If the function, he doesn't change the function. These, I will show you the RSS function, the normal calculation one, it doesn't change, but it changed the pledge part of it. Where out of the function inside, it doesn't matter. So, and when we can see, so this is the main, this is the original cost, everything based. So when we change shown parameters, you can see the very drastic effect, but you should check that this green, this line here is 1 million. So it doesn't have any much of, okay, we can increase them, but oh, the max, oh, that's good. And what it needs the other parameter to set. It means it won't preserve the value. When you change this function, the max goes down, and you need to compensate it somewhere, because as I told, if you take something from somewhere, you need to add to the equation, because the equation must be always equal. So if you set this one, and I'm just showing the members, it has a very bad effects everywhere. And has no real benefits, because the issue is this between the 1 million, I would say that is the max, and between the 0, there is no too much effect on that, and also it is put down the maximum. That's why I wanted to say that I need to do a second part of it, if you guys interested, to explain exactly how does it, this shown CIP and the others proposal works. Because, yeah, it's going back. Because it's not as easy as it looks, and also it affects a lot of other things. You know, not just, you just can play with these parameters as you can, because these are equations. So I think that was all. And maybe in the next part, I will explain exactly, because I need to create a presentation for this one too. So explain exactly what is the issue, why is the issue, and why. Because it doesn't change anything, the curve you can see. You know, so it doesn't matter if you do it put, you know, as the curve is on the bottom or top curve, it doesn't punish, because the minimum means minimum you will get if you can't get delegated stakes as much you can, and the maximum if you can, and it's independent for the function. It depends on the marketing, on this kind of stuff, you know, just or how you get saturated and full saturated. So the issue is the curve of these lines of this function. What we need to be so we're not the pledge amount or this kind of stuff. So that was all, Guy, I think. If you have any question of something is not understood, or I mean something wasn't understood, let me know. Let me try to answer, but it's not easy.
Okay, I have two questions.
Yeah.
One is, does this function for Roy here, it doesn't depend on the mandatory pool cost, but the mandatory pool cost actually makes it easier, right?
No, it considers, because you can see everything considers everything here. If you put the cost, but if you just look at here, if we put the cost 0, it will be a straight line. Okay, and I think I just, oops, I need to set back because it's affected by the shawns. Okay, because I just disabled the shawn. You know, and you can see, and I just disabled the. No, that's I just left this because this is not, don't consider here because just consider this line. So it doesn't matter if the cost and the margin zero, it will be always a straight line, you know. And that was the original intention for these revolved functions. So if we introduce cost, and as I told in the previous, the cost in percentage wise will be proportional to the stake. Lower the stake, I mean delegated stake, higher the number. Higher the delegated stake, lower the number. And pledge. So if we introduce the cost and the margin, it will always, this kind of a line of the curved line because of the function, because it's based on the function. You can't do anything. So it's
okay.
So if you put it zero.
Okay, if you set the cost to zero and some margin.
Yeah, it's exactly the same, but not as hard as effect. Because it's just if you increasing maybe the zero will be the nothing, and if you just increasing, just starting, and that's why it's hard to solve, because these local minimums will be always changed, and because it's not, you can see this, he's always moving, so you need to calculate it, and it's a cubic, and which is very hard to solve, but luckily solved it. And
so removing the mandatory pool cost
it won't help. Yeah, it won't help really, but it make FX harder because you put a fixed cost, and if you pledges less and less in percentage wise, it will be very, very high. Yeah, of course. Just imagine if you put a 10K pledge, and you can attract the members delegate to your pools, because then they can earn 24K a year without any cost, without any margin, sorry.
Yeah.
So it means nearly 2.5 times you doubled the money. So what would incentivize? Make a lot of this kind of stuff, isn't it? Because I can double my money, guys. Okay, do it. So there is no incentives to stop this behavior. We can argue what would be the good percentage of the, but so there is no magic. So just pure math. So I hope it's sorry, but I'm not a good presenter, and I did this first in my life in English, you guys, especially for this audience.
So, I think it was good. I don't think you should worry about it. Okay, but my next question is just a quick one. So we had a discussion recently, like this week, about the pledge effect with the increase of K. And
okay, we can see it. You can see here. Not just imagine, because we have it. I just set it in this 150. Okay, and okay. So I need to increase a bit, and I will disable saturation. Okay, and because this is 200, so this is a full saturated. So I think I need to manually edit the axis, so the X will become as 2-ish. Oh no, 667. The minus can be lower. Okay, and 4, and we can set the 8. Up. I missed one? Yeah, maybe a little bit. Okay, now you can see. So, okay, you can see here. So this is a full saturation point because it is a different case, 150. And you can see the effect. We just set that for the default. Oops. And I will put some 3%, and I said 4. And so you can see here is exactly the same. So the curve is same, but the local minimum is different, but it's exactly the same. And you can see the left side of it here. It has very huge effect, even when you have a 10 millions pledge, because you need to have a, I can't calculate in my head this, but a lot. So here, because you have, and when you increase so look at the max is not changing, the max is not changing, as I told, it's always, and you can go the saturation back to the 500 times. And in percentage wise one changing, because as the K increase, the saturation level is less, means a lot of delegators will leave you if you are above those 64 million, because they don't want to lose. So that's why is redistributing the value is won't really change anything. So if the K changes, nothing, just goes that the max will be the same in percentage wise. And of course, and here, sorry, is this A? Sorry, this is the A. It's free. Okay. And just check 500 or anything, and just see what is the issue with the A. So I'm just putting back to 150 now, and when we're increasing the A, because it can be very huge, the max will be the same, but the minimum, I just put it up over there, but the minimum, it will be less. You can go whatever you want, but it won't change the curve. And imagine here we are, it's much more than, than 10 millions. So it hasn't, and of course it won't change anything. I mean, you can, but the operator can earn much more, doesn't matter. It will just suffer the members. And of course, if we suffer the members, then maybe they will leave or something, but it's a dynamics. So dynamic system, so it's not as easy. So, so that's why I'm not sure why is the changing the A, because the issue is it's between the 1 million, it's the very left side of this graph, and next to the y-axis. It's a very left side, and because we are here, we as the SPs usually, because of the average pledge for all of the pools are 35K. So we are not here. We're not here in 10 million, and we even want even very few of us here in the 1 million. And so if the doesn't have a curve, no, it doesn't have effect in this small range, so that's why it is issue. And you can't do that. So just create like a straight line here and just maybe these or here in the 1K or 50K, we do some curve change. Where? 50, 10, 100K, 250K, what? If you would have a 200K for pledge, you would say, oh, 200K is good, but the 150 is not good. If you would have 100K pledge, you would get, 100K is good to change the curve, but 80K, that's not good. You need to change, they need software. So where do you draw the line? So it's not as easy as, we just can arguing these and that. And that's why the IOG scientists are very, very good in this, when I read this paper. But this cost and this ugly bastard did something, for incentivizing the pools. And that's why you can see, and I understand. So that's why I understand. So in an ideal and word, we pool operators should unite if we want to have higher pledge, And later it will, yes, become, I think, the normal, because now the other price is low, but we can, fill our bucket as much money as we can, because we are in the, first mover advantages. But by the time if it's getting adopted, other price will be high and high. A lot of big whales will jump in, and these in 1 mil pledge or less, we can have, because what I told guys, it doesn't matter if you have so I'm just, look at this. If you have just 50K stake and 50K pledge, you will earn for that 97% based on your pledge. It's good because anybody, even if they just have on 5K, they will earn 5% based on their 5K pledge. Doesn't matter. It means not only saturation, not only delegated stake, but purely pledge. This is very beautiful. That's why I think Lars and this kind of created this, because it doesn't, punish the small ones. This is not punishment. The punishment is that when these small ones can get that curve, which makes sense, of course. If they get more and more delegated state, just imagine. Sorry, but I will put it this 50. Okay.
Sorry, Paul. Instead of say punishment, can you say rewards for who pledges more? Because punishment sounds very bad to me. I don't want to punish anyone, but
no, we don't want to punish. But if we change this, they will punish. I mean, it's perfect now, because of what I wanted to show. It's not punishment here. So imagine. So it will have 50. Oops. So 50K, I will just show you, even 5K. So it means if the stake and the pledge is 5K, it means no any delegated stake, that my pledge, only my pledge, 5K. I can earn 5% a year based on that one. And if it goes up, it's always changing. If it goes up, you can see the number here. It's increasing. And if this guy with 5K can be fully saturated, see, it will have a lot of in percentage, right? 6,000%, which means 76x. Of course, because so this is not punishment here. It will be punished if we change these functions.
Listen, I have one question for you, Paul.
Yeah.
You are showing us a lot. First of all, congrats for the presentation. It's really nice. I like it very much. The question is, you are showing us all the wrong things about the formula, how it affects badly the equilibrium. But what I would like to understand is, what is the perfect equilibrium we should achieve, we should go after? Because it's something I still not sure I understand, because in my opinion, once we fix which is the best strategy, the best way forward, then we go ahead, we change, or we use the mathematical function we have for the rewards distribution. We try to fix it. But so far I've been seeing a lot of people with good arguments saying that all these functions are not good enough. But what's the goal? Because in my opinion, many people have a different approach, about a different idea about what will be the perfect equilibrium between member rewards and operators rewards. What's your idea of that?
I think there is no perfect equilibrium, but what the IOG scientists did with the K is very good. So if we decide the K as 500, we should expect in the equilibrium of 500 nearly saturated pools. But I showed you in the first slide on the RSS function and the reward calculating function that in the ideal world, if we would have k number only pools with fully saturated, there wouldn't be any left over for the others. So that's why there won't be k number of fully saturated pools. It will be always some fluctuations. Okay, but in the ideal world, we would like to have at least k very high saturated pools and the leftovers, lot of tails, we called it tails, and it doesn't matter because somebody in Africa can have some in village and they just got put 5k, that's okay. It doesn't mean any security hole because the security based on the stakes. And if there are 500 pools with high saturation level, they create the blocks, and they secure the mail. But these small pool, 5k, can create a block a year. It means he or she will get the reward, 5% of based on their pledge, and happily leave. So, and the ranking, what I'm not talking about it, is just like a work like enzymes, which make reaction million times faster. So because if we won't have ranking, these based on math, of course, if it is this line curved wouldn't exist, will eventually converge to the equilibrium. So there is no doubt it will, but that's the issue. These ugly cost and this kind of which screwed up a little bit. But for really long term, it doesn't matter. It will work either even with this function, but it's very long, maybe 10 years or 5 years, when the price and everything. So because it's a lot of, this is a multifactorial function, just it's a lot of different, forces would change this whole system. So we can't, and that's the issue. We can't pick up one. We can't pick up A. We can't pick up K. We can't pick up cost. Because it's dynamic, very, very dynamic system. But mathematically proven, it will converge to the equilibrium. But it has some glitch.
Can I ask something? The increase of K, from my understanding, by keeping the minimum cost, made it this minimum cost problem even a little bit worse. And by increasing it another time now, not only from 150 to 500, but even doubling it again to 1000, will make the maximum saturation point very much lower.
Yeah.
And the minimum cost remains the same fixed thing, so we will make it worse again.
Yeah, of course,
right?
because it's fixed cost and it's relative. I mean, proportional to the stake, and
so if we talk about how much if it would make sense to go to K1000 in 3 months, then it would require also talking about minimum costs, and the other side of minimum cost is if there is no minimum cost with even smaller pools, so the 32 million pools, then it becomes very difficult to run it sustainably.
Yeah, but that's why I told it's very dynamic system, because you should if you do some investment, you do some risk analysis. Just it's not just put money in it. So we are SPOs, like the first mover advantages. Sorry, we're thinking a bit differently, because we are not businesses. We are just maybe just roller. But when the real business will come in, and I'm not talking about exchanges and this kind of guys, but the real one when the others getting adopted by the time, you know, and like when you shove to the red, yeah, to the bulls, you know, it will comes and they will come. So because yeah, it's very hard because you need to think to the business. What is the business? So if I want to business for long term, maybe you can create a 5-year strategy to, you know, and okay, I will invest this kind of money. But in this current situation, it's not how we are thinking, because we want to gain more money, you know, just like the one PCT. So just put less and less, you know, pledge and creating more, because we don't, every business has some certain money to invest, you know. So, and if I can split this investment to smaller portions and create more pools and gain more reward or profit, yield more profit, you will do it. So it's of course it balances the cost and everything, but it's real business decisions, and it is like us, like just playing with VMs and this kind of stuff. It will eventually come by later, and because if Cardano blockchain is successful, it means it will have a K number of very, very, very well thought pools. I mean, not K, but high percentage of them, because, you know, it's like a feedback loop. When, you know, have a stronger business into it, more to come, more will come, you know, because it can see this Cardano blockchain is backed by very solid businesses to protect them. Of course, a lot of others are small pools, maybe alliances can grow up, but by the time years and years, you know, it will be very, very different than now when we can do this. But the issue is with that, what I told is a lot of pools by one entities. But yeah. Okay, I'm just reading some group chat because, oh, sorry. Whoa, 1.5 hours. Oh, God.
Yeah, it was very interesting, and thank you very much.
You're welcome, guys. Hopefully it makes, so it's very complex, and yeah, we can't see through complex things. I'm same as you guys. I'm not differ from you. I can't see through complex things, you know, because that's why we create models to understand, or small like this presentation to understand how it works, and but still very complex. So, and also there's a lot of different angle of this, like the financial, you know, economic market and behavior and blah 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 blah. So yeah, okay. So
thanks, pal.
I think if there is no question, we can call it a day. And
yeah, thanks a lot. And what you said, you found a way to actually solve the problem. So I would be really interested to see how this works, and maybe we can do a sip on this and push it.
yeah, but I'm not a scientist, so that's why scientists should do this. You know, we can have ideas. Yeah, we can have ideas, but yeah,
I don't think Sean is a scientist either, so it should be on the same level. But IOG is at least discussing his SIP, so we should also discuss your ideas, I think.
Yeah, okay. So, okay, guys, any questions? Or we can call it a day.
Yeah, thanks for the presentation.
Okay.
Yeah, thank you, Pat. It was great.
Okay, I'm just have a nice
Thank you.
share. Okay, see you guys.